Good afternoon, student. In this video, I am going to discuss some more questions from exercise 10.3. Now, we know that the normal form of equation is x cos omega plus y sin omega equal to p. Now, the question number 3, reduce the equation into normal form and then find their perpendicular distance from origin and angle between perpendicular and the positive x-axis. Now, for reducing your equation to the normal form, the constant on the right hand side should be positive, because on right hand side we are going to have p, that is distance. It is always positive. So your equation is minus x plus root 3y equal to 8. Now divide both side by under the root the coefficient of x square. This is under the root coefficient of x square plus coefficient of y square. So here you have root minus 1 square plus root 3 square. 1 plus 3 is 4. So this is minus x by 2 plus root 3 by 2 equal to 8 by 2. Now compare this equation with x cos omega plus y sin omega equal to p. So your p will be 4. Cos omega is minus 1 by 2 and sin omega is root 3 by 2. This is cos omega is minus 1 by 2, sin omega is root 3 by 2, p is 4. Cos negative, sin positive, only in the second quadrant. Or you can also do like this, cos negative, second and third, sin positive, first and second. So that means your common quadrant is the second quadrant. Right? In second we'll write pi minus theta. Pi minus, sin is root 3 by 2 at pi by 3. So this is 2 pi by 3. One more question. Y minus 2 equal to 0. So y is 2. Again divide both side by the under root the coefficient of x square. There is no term of x, so the coefficient will be 0 plus coefficient of y square is 1. So this is 0x plus 1y is 2. That means if you compare these two equations, cos omega is 0, sin omega is 1 and p is 2. So omega is pi by 2, right? And the distance of perpendicular distance of line from the origin is 2. Next is the distance of point from the line. Just look here. If we have to find the distance of point from this line, there are infinitely many ways to find the distance of a point from line. But we'll always find the shortest distance, and that distance will be always in the perpendicular direction. So the distance of point from the line is the length of this perpendicular drawn from the point to the line. So apply the formula is distance of point P x1 y1 from the line ax plus by plus c equal to 0 is a into x1. Here b into y1 plus c with the mod divided by under the root the coefficient of x square, that is a square plus b square. Question, find the distance of point minus 1 1 from this line. So your line is 12x plus 72 equal to 5y minus 10. So the equation is 12x minus 5y plus 82 equal to 0. Now find the distance of this point from the line. Take mod 12 into x1 here is minus 1 minus 5 into y is 1 plus 82 divided by under the root the coefficient of x square, that is 12 square, plus coefficient of y square is minus 5 square. So this is minus 12 minus 5 plus 82 divided by 144 plus 25 is root 169. So this is 65 by 13. Answer is 5 units. Question number 5. This is very important question. Find the points on the x-axis whose distance from this line is 4 unit. Now, let the point on x-axis is a 0, because on x-axis y coordinate is 0. Now, distance of this point from this line is 4 units. So, your equation is 4x plus 3y equal to 12. Now, apply the distance formula. This is 4 equal to mod 4 into a plus 3 into 0 minus 12 divided by under the root the coefficient of x square, that is 4 square, plus coefficient of y square. So this is 4a minus 12 divided by 16 plus 9, 25 root will be 5. Now whenever you are going to remove mod, we'll take both positive as well as negative sign. First, by taking positive sign, 4a minus 12 by 5 equal to 4. Simplify this equation, a will be 8. Second, by taking negative sign, 4a minus 12 by 5 equal to minus 4. So this a is minus 2. So that means you will have two answer. Either point is 8, 0 or minus 2, 0. The distance between two parallel lines. Parallel lines means the coefficient of xy will be same or they are in proportion. If they are in proportion, first make them same. The distance is mod of C1 minus C2. It is important to have the constant on one side, either on the left hand side or both the constant on the right hand side. Mod of C1 minus C2 divided by root a square plus b square. Find the distance between two parallel lines. Just look here. Coefficient of x and y are same. Here let C1 is 31. Then C2 will be minus 34. Apply this formula. Mod of C1 minus C2 divided by under the root the coefficient of x square plus coefficient of y square. This is 31 minus of minus 34 divided by root coefficient of x square 15 square plus 8 square. 31 plus 34 is 65 upon root 289. That will be 17 unit. Next question. Find the equation of line parallel to this line and passing through the point. Now, this is the given line. We find the slope negative of the coefficient of x divided by coefficient of y, 3 by 5. Now the required line is parallel to this line. That means their slope will be equal. So the slope of new line is 3 by 4. And the new line is passing through the point minus 2, 3. We know that the equation of line having slope m and passing through the point x1, y1 is y minus y1 is m into x minus x1. So this is y minus 3 equal to slope 3 by 4 into x plus 2. Simplify your equation. This is your answer. Find the equation of line perpendicular to this line and having x-intercept 3. Now this is given line. Let m1 is the slope of this line. Now the slope is negative of the coefficient of x, that is 1, divided by coefficient of y, that is minus 7, is 1 by 7. Let m2 is the slope of required line. Since both lines are perpendicular, so product of their slope will be equal to minus 1. So m1 into m2 is equal to minus 1. From here m2 is minus 7. Now the line is having slope minus 7 and x-intercept 3. X-intercept 3 means this line is cutting the x-axis at a distance of 3 from origin. That means this line is passing through the point 3, 0. So equation is y minus y1. Y minus 0 equal to slope minus 7 into x minus 3. So this is your answer. Find the coordinate of foot of perpendicular from this point to the line. This is also very important question. You have to drop a perpendicular from the point minus a3 to this line and then find the coordinate of this foot of perpendicular. Let m alpha beta be the foot of perpendicular from this point to this line. Now we need to find alpha and beta, two variable. For finding two variable, we need to have at least two equation. Now since AM line is perpendicular to line L, so product of their slope will be equal to minus 1. Let M1 is slope of AM, M2 is slope of L. So M1 into M2 equal to minus 1. Now slope of line AM, M1 is passing through 2 points. So this is beta minus 3 divided by alpha plus 1. M2, slope of line L is negative of coefficient of x 3 divided by coefficient of y minus 4, 3 by 5. Since the lines are perpendicular, so m1 into m2 equal to minus 1. Now solve this equation. So your equation will be 4 alpha plus 3 beta equal to 5. The second condition, the point M lies on this line. If this point lie on this line, this point will satisfy this equation. This is 3 alpha minus 4 beta minus 16 equal to 0. Now you have these two equations. Solve these two equations using elimination method to find the value of alpha and beta. Multiply this by 3 and this by 4. Add them. Beta is minus 49 by 25. Put the value of beta in either of these two equations. So alpha will be 68 by 25. So your answer is 68 by 25 and minus 49 by 25. If P is the length of perpendicular from the origin to the line whose intercept on the axis are A and B, then show that this result is true. Now first we'll write the equation of line which is having A intercept on x-axis and B on y-axis. Equation will be x by A plus y by B equal to 1. Now P is the perpendicular distance of this line from origin. So apply the distance of point from line. P is mod 0 by A, replace x with 0, replace y with 0, minus 1 divided by under the root the coefficient of x square is 1 by A square plus here 1 by B square. So this is 0, 0, minus 1. Take mod, it will be positive. Next step, do cross multiplication. This is root 1 by A square plus 1 by B square is 1 by P. Now for proving this result, just do the squaring on both sides. So this is 1 by A square plus 1 by B square is 1 by P square. Hence proved.